folks. We're going to be talking about K sub C and then some specific cases of K sub C. I'll start by finishing up our Year 12 revision by talking about Le Chatelier's principle. And Le Chatelier's principle is basically, why do we care about K sub C? Like, what does it do for us? Why are we doing these calculations? The reason is because we have determined by experiment what K sub C is for a given concentration, pressure, temperature, and any catalysts for a given reaction. K sub C is always determined by experiment, which means in English language means that you will be given K sub C. When you are given K sub C for a given reaction, and you know the concentration, pressure, temperature, and catalyst match what you're given for K sub C, you can then calculate the concentrations of the things in the reaction. If a system is in equilibrium and subjected to a change will occur in the system to counteract the change. Basically what that means is K sub C never changes for a given reaction at equilibrium. Never, ever changes. So K sub C is nailed in place. So what that means is if I take that reaction and I change the concentration of the products, if I increase the concentration of the products, the concentration of the reactants is going to decrease. If I decrease the concentration of the products, the concentration of the reactants is going to increase. The value of the equilibrium constant must remain the same. Therefore, the concentration of the reactants must change to counteract that change. And that is what you learned at level 2. If you are having a hard time remembering that, I can point you towards some resources for that as well. Talk to me in class or look at the comments on this video. Okay, so some specific cases with K sub C, and this is where we get into the level 3 stuff. Specific case of K sub C is what we call K sub S. K sub S is the specific case where we are dealing with a saturated solution. A saturated solution, as we defined in class the other day, is any solution where no more solute can dissolve into solution. So basically, take a kitchen tumbler, put salt in it until you can't dissolve any more salt into the water. The water is full of salt. You can't put any more in. To continue to use that example of salt in water, we've got sodium chloride, which is table salt, in equilibrium, solid and aqueous, as we can see in this reaction here. This is at equilibrium. It is at equilibrium when it is saturated. And we can write a K sub C equation for that. And that would look like this. K sub C equals concentration of sodium times concentration of chloride over concentration of sodium chloride. However, you may have noticed this here. The sodium chloride is a solid. We do not include solids in our reactions. So what actually we'll end up with is this. Concentration of sodium times concentration of chloride. And that is what we call K sub S. We can generalize that to concentration of A times concentration of B. We put plus and minus on those just to indicate the fact that we're talking about ionic solids here. Ionic solids consist of a positive and a negative ion. K sub S refers to the concentration of the positive ion times the concentration of the negative ion. And that works great for things like sodium chloride where there's just one positive and one negative ion. But that's not always the case. Sometimes you have things like this, where you have one positive and two negative ions. Or it could be two positive and one negative. We'll use one positive and two negative as our example. That can also be an equilibrium. The equilibrium state looks like this, that you see here. And the equation for that looks like what you see here. Concentration of concentration of calcium times concentration of hydroxide squared over concentration of calcium hydroxide. However, once again, we do not include the concentration of the solid in our reaction. Doesn't exist. So we end up with this K sub S equation. Concentration of calcium times concentration of hydroxide squared. And again, we can generalize this to K sub S for what's called an A2B or an AB2 reaction is concentration of A times concentration of B squared, or concentration of A squared times concentration of B by itself. And that just depends on whether it's the positive or the negative ion being with two with 2 moles for the 1 mole of the other one. There are other cases. There are times when there's 3 negative ions to 1 positive ion or more than that. We're just going to deal with the cases of where they're in a 1-to-1 ratio or a 2-to-1 ratio. And the 2-to-1 ratio can be 2 positive to 1 negative or 2 negative to 1 positive. So when you're calculating this, you set it up like this you see here. K sub s equals one of those depending on what you're dealing with. But there's a little bit of an easier way to think about that. And that is using a little bit of math trickery. So using the same equation, calcium hydroxide solid is in equilibrium with calcium ion and 2 moles of hydroxide ions. We can end up with the same generalized equation here, A times B squared, or A squared times B. In this case, it's A times B squared, that first one. Let's call the concentration of the ionic compound S. So the concentration of calcium hydroxide is S. We're just going to give that variable a name. That name is S. And that concentration can be looked at like this. So concentration of calcium is the same as the concentration of calcium hydroxide, because for every mole of calcium hydroxide, we have 1 mole of calcium, 1-to-1, 1-to-1 ratio. So that is this S right here. You do not include the bracket, sorry, that's a typo on my part. For the hydroxide, you have 1 mole of calcium hydroxide, but 2 moles of hydroxide ions. So that you're going to end up with 2S. And then you square that, because that's how you work out your equilibrium constant. So you end up with K sub S equals S times 2S squared, because we're calling the concentration of the ionic compound S. And that math can be simplified a little bit to look like this. K sub S equals 4S cubed. Remembering that S in this case is the concentration of the ionic compound. So the concentration in this case of calcium hydroxide. K sub S, concentration of calcium hydroxide, is S. Which means that K sub S, following on from the calculations we've done earlier, is equal to 4 times the concentration of calcium hydroxide cubed. That's it. Ask me questions in class if you have any.